Bolos, a 19-years-old petite woman from Bachelor of Science in Mathematics or BS Math 2A, your speaker for this video, and I'm here to help you understand matrix addition. So let's get started.
But before I discuss matrix addition, you first need to understand what does matrix means, right? So 1, 2, 7, and 8, this is just a row of 4 numbers and it can be represented in different ways. You can write it as an array of numbers vertically like this or horizontally like this. And there's another way in which you can write the 4 numbers, the first 2 numbers in the first row and the last 2 numbers in the second row. All these 3 things you see are called matrices, an arrangement of rows and columns. Now that you have a few ideas of a matrix, here is the proper definition of matrix. A matrix is an rectangular arrangement, but what rectangular arrangement? It can be anything, like numbers, letters, or the characters. A matrix is made up of rows and columns. The first matrix above has 1 column and 4 rows, and the second matrix above has 1 row and 4 columns, and the third one has 2 rows and 2 columns. But you must remember that there is one important condition you need to keep in mind. Each row needs to have equal numbers of elements. For example, the first matrix above shows that each row has 1 element. And each column also needs to have equal numbers of elements, like the second matrix above shows that each column has 1 element. Now here are some examples. Elements K and Y in the first row and elements L and A in the second row. It is a rectangular arrangement because each row has 2 elements and each column has 2 elements, so it is a matrix. What about this one with 3 elements? Is it a matrix? The first row has 1 element but the second row has 2 elements, so it is not a matrix. What about this one with 2 elements? The numbers of element in the first row is the same as the number of element in the column, so it is a matrix. Lastly, this one with 5 elements. The number of element in each of the columns and row is not the same, so it is not a matrix. Now you know the proper definition of a matrix. The next one I will discuss are few super basic things you need to know about every matrix. The first one is a matrix are named using capital letters. For example, matrix with 4 elements, 2 rows and 2 columns. You can call this one a matrix A. Second one is what are the elements in the matrix. Elements are nothing but the components of the matrix. Example, matrix A has 4 elements, which are 1, 4, 2, and 6. And the elements of a matrix do not have to be numbers. They could be anything. The third one is what is the order of the matrix. Order are the number of rows and then the number of columns. Like for example, matrix A has 2 rows and 2 columns. The order of matrix A is 2 by 2. Don't forget the number of rows first and then the number of columns. Lastly is what is the position of an element. Every element in a matrix has a unique position, but to know the position of an element in a matrix, you need to look at the row in which it is placed and then the column. Yes, row, column. For example, in matrix A, what will be the 1th and 1th element or the A sub 1, 1? Remember, row first then column. So the A sub 1, 1 is 1 because first row and the first column. How about A sub 1, 2? First row and the second column. A sub 1, 2 will be 4. This goes on and the last element will be the A sub 2, 2, second row and second column. It will be number 6. Now that you understand what does matrix means and know the basic things you have to know about every matrix, I can now discuss what does matrix addition is. Adding 2 numbers is easy, like 2 plus 8 is equal to 10 and 5 plus 9 is equal to 14 and so on. But how about 2 matrices added? Before I discuss on how they added 2 matrices, you need to know one simple rule. 2 matrices can be added only if they have the same order. Yes, you heard that right. Both matrices have to be of the same order for the addition to be possible. Now let me give you 2 matrices and you have to analyze it if they can be added or not. The first matrix is 1, 5 in a row and the second one is 2, 4 in a column. Can these two matrices be added? To know if they can be added, you have to look at the orders. The first matrix has 1 row and 2 columns. Its order will be 1 by 2. And the second matrix has 2 rows and 1 column. Its order will be 2 by 1. Now, are the orders same? No, they are not. This tells us that these two matrices cannot be added. Remember that orders different cannot be added. How about this one? The first matrix has an order of 2 by 2, and the second matrix also has an order of 2 by 2. They have the same order, so it can be added. Here is a way to remember how to add two matrices. Simply add the corresponding elements. But what do I mean by corresponding elements? The corresponding elements are the elements which have the same positions. In these two matrices, A and E are corresponding elements. Both are in want and want element. And the B and F, C and G, and lastly D and H are also corresponding elements. Now, this is how the addition of corresponding element is done. First, A plus E, the sum of A plus E will be the want and want element in the final matrix. A plus E will be equals to AE. This goes on up to the 2 and 2 element, which is D plus H, and it will be equals to DH. Just remember that when adding two matrices, they need to have the same order. Then just add the corresponding elements which have the same position. And also, the sum of those two matrices will always be the same as the order of the individual matrices. Here is an example. The first matrix has 4 elements, 2 and 6 in the first row, 7 and 3 in the second row. And also, the second matrix has 4 elements, 3 and 5 in the first row, 4 and -1 in the second row. They have the same order, which is 2 by 2, so it can be added. Now, let's add the corresponding elements. The A sub 1, 1 in the first matrix, which is 2, plus to the A sub 1, 1 in the second matrix, which is 3. Then, in A sub 1, 2, which is 6 plus 5. Then, in A sub 2, 1, which is 7 plus 4. And lastly, in A sub 2, 2, which is 3 plus -1. Now, just solve it, and 2 plus 3 in A sub 1, 1 is equal to 5. 6 plus 5 in A sub 1, 2 is equal to 11. 7 plus 4 in A sub 2, 1 is equal to 11. Lastly, 3 plus -1 in A sub 2, 2 is equal to 2. This is the sum of those two matrices. Here's another example. Let matrix A be equals to 3 by 3 matrix that has an elements of 2, 3, 6 in first row, -1, 7, 8 in second row, and 4, 2, 5 in the third row. And then matrix B be also equals to 3 by 3 matrix that has an elements of 1, -4, 10 in first row, 2, 13, 1 in the second row, and -2, 3, 7 in the third row. Now, solve the sum of A and B. A and B has the same order, which is 3 by 3, so you can proceed to add it. 2 plus 1 in A sub 1, 1, 3 plus -4 in A sub 1, 2, 6 plus 10 in A sub 1, 3, -1 plus 2 in A sub 2, 1, 7 plus 13 in A sub 2, 2, 8 plus 1 in A sub 2, 3, 4 plus -2 in A sub 3, 1, 2 plus 3 in A sub 3, 2, 5 plus 7 in A sub 3, 3. 2 plus 1 is 3, 3 plus -4 is -1, 6 plus 10 is 16, -1 plus 2 is 1, 7 plus 13 is 20, 8 plus 1 is 9, 4 plus -2 is 2, 2 plus 3 is 5, and lastly, 5 plus 7 is 12. Matrix A plus matrix B is equals to matrix C, which is this matrix. Remember, matrix are named using capital letters. How about solve the difference between A and B? The rule in matrix addition is the same in matrix subtraction, meaning the numbers of rows and columns must be the same when adding or subtracting the matrices as well. Now, A and B have the same order, so you can proceed to subtract it. 2 minus 1 in A sub 1, 1, 3 minus -4 in A sub 1, 2, 6 minus 10 in A sub 1, 3, -1 in minus 2 in A sub 2, 1, 7 minus 13 in A sub 2, 2, 8 minus 1 in A sub 2, 3, 4 minus -2 in A sub 3, 1, 2 minus 3 in A sub 3, 2, 5 minus 7 in A sub 3, 3. 2 minus 1 is 1, 3 minus negative 4 is 7, 6 minus 10 is negative 4, negative 1 minus 2 is negative 3, 7 minus 13 is negative 6, 8 minus 1 is 7, 4 minus negative 2 is 6, 2 minus 3 is negative 1, and lastly, 5 minus 7 is negative 2. Matrix A minus matrix B is equal to matrix C, which is this matrix. So that's how you solve two matrices. Now let's have a quick review. A matrix is a rectangular arrangement of anything. It can be numbers, letters, or characters, and it's made up of rows and columns, and named using capital letters. Each row and column needs to have equal number of elements. Elements are the components of matrix. It can be anything. Order the number of row first and then the number of column. M for rows, N for column. M by N, not N by M. Position of an element. Every element in a matrix has a unique position. To know the unique position, you look at the row in which it is placed, then the column. Row, column. In matrix addition, two matrices can be added only if they have the same order. Then, simply add the corresponding elements which have the same position. Then, the order of the sum will always be the same as the order of the individual matrices, and the number of rows and columns must be the same when adding or subtracting the matrices as well.